Thank you very much. And thank you very much to all of you guys to prefer to be here. You could be in another room, another lecture, but you decided to be here. I really appreciate. I'm from Dianyx Innovation, and in the next 10, 15 minutes, I'm going to talk about this little picture here, which is the technology was baked in university and now is ready to be used with many people. So this is the outline of my presentation. Briefly, I would explain who is Dianyx Innovation, and then I would explain the sleep and the sleep monitoring market, and then also how we can treat sleep, and I would show you some results, and finally, I would conclude this talk with conclusion. So Dianyx is the medical device company founded 2020. We mainly focus on sleep, and our target is to treat the obstructive sleep apnea. Today, I'm going to present this product, Tesla, technology enhanced sleep appliance. Basically, is the technology that's going to attach to the mouth guard, and we wear the mouth guard over the night, and then data transfer from the hardware to the cloud, and physician can have access to those kind of data related to the sleep. Dianyx, fortunately, has a different member with a different background. We have a neuroscience, a dentist, and myself that has a engineering background. So let's focus on the sleep and sleep monitoring market. So far, the market size for sleep is predicted to be $1 billion. And the most important thing is 80% of the population are undiagnosed. So imagine if we can diagnose these remaining 80%, that number gonna increase significantly. Unfortunately, untreated sleep apnea also going to create the other diseases like diabetes, hypertension, stroke, which if we combine the sleep apnea treatment and those associated diseases, it's going to cost around 150 billion for the health. So normally, we treat the sleep apnea by using that CPAP. CPAP basically is the mask. We wear it over the night. That's the ugly thing. It's not very comfortable, and it's not preferable by patient. The other method that we can treat the sleep apnea is using that mouth guard, which call it oral appliance therapy. And there is a way which is the rarely can happen, and that one is the surgery, which can cost up to 40,000. So oral appliance therapy, basically that the mouth guard, we put it on the mouth, and that mechanism push the lower jaw front, and then we can have a large airflow. So at this moment, there is no really feedback from that mouth guard. And the feedback directly comes from the subject. In very rare cases, physicians prescribe using the mouth guard plus pulse oximetry over the night, and then they do some correlation to understand that really works or not. So then here, our motivation is that to make that mouth guard kind of smart, that can provide the information related to the sleep. So we started with this first iteration of our product. Is based on the PPG sensor. If you are familiar with the PPG sensor, it's the optical sensor. Basically, we send the optic to the brain and we measure the reflection, and that reflection can give some information related to the heart rate, blood oxygen saturation. We started with that ugly, uncomfortable structure, which unfortunately also resulted in our NIH grant rejection. And then absolutely is obvious that's not comfortable even when you want to wear it over the night. Actually create a more problem rather than the treating. So then we came up to use a flexible hybrid material. We put all the sensor on the flexible structure that can be bended. As you can see, we can have exactly like arc shape of the mouth, and it's lightweight. It doesn't block anything, and the patient can wear it easily. So we have a number of sensors in the device. One of the main one is the PPG sensor, which we use it to extract the heart rate and SpO2, blood oxygen saturation. The other one, we have axiometry, which we determine the head position over the sleep. And then we have also a temperature sensor that measure the oral cavity temperature. And based on oral cavity temperature, I can identify the breathing route. The patient breathed through the mouth or nose. So let's focus on the result. Let's focus on the result. The first thing that we did, we test capturing PPG signal from inside the mouth and with those signals that we normally take it from the fingertip. So here we have a flexible, which is our developed design, capturing data from inside the mouth, and the other one in the middle is the reference measurement, which coming from the fingertip. From the bare eyes, we can see those signals are very similar to each other, but to quantitatively show that those are very similar, we did cover spectrum of each signal. As you can see, both signals overlay each other very nicely. The only difference is the magnitude, and that magnitude is because of the different tissue inside the mouth and your finger. Fortunately, this correlation was not only dependent on the wavelengths of the infrared, also we saw the same similarity in the red, because for the calculating the SpO2, we need to have two different wavelengths. And now we said we are the company working on the sleep monitoring. I explained you the hardware. Now the most important is for us to identify the parameter related to the sleep. So for the physician, several parameters are very important. The first one is the total sleep time. And the other one is the non-rapid eye movement and rapid eye movement, RAM. And the other parameter, which is very critical, is the apnea-hypopnea index, shortly called AHI. And basically, AHI classify the severity of the OCL. So we use the PPG sensor information to extract all those information. The first one on the here I have x-axis represent the time that the patient was wearing, and the y-axis represent the heart rate. We can see that this heart rate over the time is changing. Sometimes goes high, sometimes goes down, and those going high of heart rate is the indicator of the RAM. So basically, we can determine that each RAM episode. And now, as I said, the other parameter which is important for the physician is AHI, and AHI can be extracted from the blood oxygen saturation. Again, the x-axis is the time, and the y-axis is the blood oxygen. Every desaturation can be counted from that plot, and then we are able to identify an AHI. So that's the AHI of the 3.445, which is identified that this patient was the normal patient, didn't have it. Other parameter which we can extract is the oral cavity temperature. This is again the oral cavity temperature over time. You see sometimes there is a desaturation in the temperature, which is identified as a person is changing the breathing rate. On the other hand side also is the accelerometer output. We know that the output of the accelerometer is very general, and we can identify the patient was sleeping on the prone or was supine position. So as a conclusion here, we proposed a new approach for monitoring the sleep stage. And the first thing that we did, we showed that the signal that we capture from inside the mouth has the same quality as one collected from the conventional fingertip. And since we are using the flexible hybrid material, we can bend the device, and this kind of monitoring system can be attached to the current available mouth guard. So thank you very much for your listening, and then I'm open to the question.